Fusion Mobile, quality e-learning experience on the go.
The objectives of this particular tutorial, this first class, is to look into what chemistry is. We talk about the scientific method and the benefits of chemistry to our everyday activities, and also to identify some career opportunities that the knowledge of chemistry presents us with. So, the first question we ask ourselves is, what is chemistry? Chemistry is the study of the composition of matter and the changes that matter do undergo. Well, I can tell you, everything that we see around us is made up of matter, be it of one form or the other. So basically everything around us is a chemical, be it water, be it air, contains chemicals. So chemistry simply is study of chemicals and their reactions, which is basically study of matter, the composition of matter, and the changes that matter do undergo. And that leads us to how scientists go about their observation. That talks about the scientific method. Scientific method is a logical, systematic approach to the solution of a scientific problem. How do we go about the scientific method? The first thing, the scientific method involves 5 steps which may follow each other in a couple of loops. The first thing is observation. That's identification of a problem, locating a problem. For example, I get into a particular location and I discover that, oh, I'm walking on the road and I'm thinking, how can I get to where I'm going faster and with much ease? That is an observation. I'm sweating, I'm stressed, I need a way of getting there. That's an observation. Make observation, and this observation leads to what is known as hypothesis, an explanation for a situation, for the observation, or probably an explanation for a proposal of a solution to that problem. Now, after the hypothesis is usually tested via experiments. Now, the experiment is a procedure done to test the hypothesis to see whether it follows, whether it is correct or not. Now, hypotheses and experiments may follow each other time and time after. An hypothesis may be wrong, leading us to having a new hypothesis under experimentation. And after an experiment, we may find out some new things and then need to go and come up with new hypotheses. Our experiments may open up to us new questions, which means new hypothesis. And at the end of the day, when all these are being resolved, come across what we know as the theory. The theory is a well-detailed explanation of all the observations. It does not create any room for predictions. We are not guessing, we are not assuming. We are very sure, we are very definite. And in theories, of course, it explains all the observations that has been noticed. So in the course of the experimentation, you observe and you also come with hypothesis. And at the end of the whole thing, you come up with the scientific law. Scientific law simply is a statement that summarizes the results of the explanation. Does not usually explain, but it's the theory that does the explanation. Of course, scientific law simply states out what it is, just like we have in the gas laws and others. The ionic theory does the explanation of how the theories are, how the ions are being formed and all. But in the gas laws, it just states the law. It does not really go into much details of explaining the law, but we still have the gas theory where the explanation of how the laws were created is itemized. Now, this diagram we're looking at shows how we go about going about our scientific process. Of course, observation is always the first thing. Observation leads to hypothesis. The hypothesis makes us go to do some experiments. After doing experiments, you may need to go back and get new hypotheses because of new observation noticed during the experimentation, or you may proceed to theory, and then your theory also may lead you to go and find out more information about whatever you have been told, which may lead to modification of theories where necessary, and eventually we come to what we know as the scientific law. which is a summary of everything that we are being taught, we have been studying. Now, speaking of the fields in chemistry, chemistry can be itemized into 5 major fields, but here I have like about 7 fields. We have the organic chemistry, which is the chemistry that deals with compounds of carbon. We have the inorganic chemistry. There's the chemistry that deals with other compounds, not carbon. We have the biochemistry. That's the chemistry that focuses on life. Now, I have the analytical chemistry. That's chemistry that analyzes or looks into the composition of matter. We have physical chemistry. That's chemistry that deals with rates, mechanisms, and changes, how changes occur. We have pure chemistry. That's chemistry in the line of chemistry, just for us to understand how chemical compounds do act. And we have what we know as the applied chemistry. That's the chemistry that is studied majorly for the function of application in another particular field. Of course, chemistry is very important in almost all fields in life, especially all scientific fields, because in engineering it is required for material selection. Understanding of elements lead us to the creation of alloys, metals, metalloids, and all those things. So, without the proper knowledge of chemistry, we would not know how to come about most of these particular items. We don't know how to come about the selection of materials. Also, it is also very important in medicine. Of course, many of us know chemistry, we hear chemical, we hear about drugs, medicines. That's what comes to our head when we hear chemicals. Well, chemicals are not just those, but especially in pharmacy, well, we do have chemistry playing a very large role. Even in fact, the entire life is all about chemistry. Everything in life is about chemistry. Also, when it comes to exploration of the earth, exploration of the space, exploration of everywhere, general study of the environment. You want to know about anything about matter. About, of course, matter is anything that has weight, has mass, and occupies space. So, and we are looking at into if you're looking into the constituents of anything, you would also be referring to chemistry. So, say chemistry is very relevant in all science related subjects, and that sums it up in this particular class. Join us in the next class.